Hey everyone, in this video we're going to be talking about the interior angles of polygons. Specifically what I want to talk about is the sum of the measures of those interior angles of the polygons. So what we're going to do is we're going to develop the formula on how we find that sum, and then I want to show you how to use the formula in a couple different examples. So what we're going to start off with is we're going to take a look at several different polygons, each with a different number of sides. And what I want to do for each of these is I want to find the sum of the interior angles of these polygons. So let's start off with a triangle because we already know the sum of the interior angles here. So we know the triangle sum theorem. That theorem tells us if we add up all the angles on the interior of the triangle, we know that it's going to sum up to 180 degrees. No matter what the triangle looks like, no matter how big or how small, the interior angles always add up to 180. So because we know that fact, that theorem, we can use that as we add more sides. So for example, this is a square, but for any quadrilateral, what I want to do is I want to split this up into triangles because I know each of those triangles has a sum of 180. So if I start from one vertex and I draw in all the possible diagonals I can, here you can see that I split my quadrilateral into two triangles. So I have one triangle here, a second one here. Both of those triangles each have a sum of 180. So my sum is going to be 2 times 180. So the sum in total is going to be 360 degrees. If we keep going, again, I'm going to start from one vertex, draw in all the possible diagonals from that vertex. So in the pentagon, we have 1, 2, 3 triangles. Each of those triangles has a sum of 180. So 3 times 180, my total sum is going to be 540 degrees. And lastly, let's take a look at this hexagon. So starting from a vertex, we'll draw in each of the diagonals. And here we have 1, 2, 3, 4 triangles. And again, each of those triangles has a sum of 180. So 4 times 180, our total sum for the hexagon is going to be 720 degrees. So now let's generalize this. So we have one triangle, and then as we add sides, the number of triangles is increasing by 1 each time. Okay, so that means there's a specific pattern here. But how does the number of triangles relate to the number of side lengths? So in the quadrilateral, we had 4 sides, and we ended up with 2 triangles. The pentagon, we have 5 sides, and we ended up with 3 triangles. And for the hexagon, we have 6 sides, and we ended up with 4 triangles. So as you can see, the number of triangles is always 2 less than the number of sides. And that makes sense because if I pick out one vertex to start from, there are 2 vertices that I can't draw a diagonal to. So these 2 sides here, because they're adjacent to this vertex, I actually can't draw in a diagonal to these 2 vertices. There's only 2 opposite vertices that I can draw diagonals in, splitting this into 3 triangles. So if I have a n-sided polygon, the way that we find the total sum of the interior angles, we want to split it into triangles. So n minus 2 is 2 less than the number of sides. This represents the number of triangles I can split my shape into, and then each one of those triangles has a measure of 180, and that will give me the total. So n minus 2 times 180 gives me the total sum of the interior angles of the polygon. So let's use that in a couple different examples. So my first example, I have a hexagon here, and I just want to find the value of x. So as we saw in the intro, we know that the sum of the interior angles of a hexagon is 720. But if we forgot or we didn't know the way that we could find our sum, so the sum is equal to n minus 2 times 180. So we have 6 sides. So 6 minus 2 times 180. That simplifies to 4 times 180. So the total sum is 720 degrees. So knowing that, now we can set up an equation that will allow us to solve for x. So if I take all the angles, all 6 of the angles on the inside of that hexagon, and I add them together, we know that that has to add up to 720 degrees. So x plus these other 5 angles adds up to 720. So if I want to find the value of x, let's just subtract all of these other 5 from 720. And doing that calculation, we end up with a value of x of 107. So there's our missing angle. So just to summarize that process, we can use our formula n minus 2 times 180 to find out the sum, and then add up all the angles, set that equal to 720, creates an equation that we can solve for x. Now, the formula, n minus 2 times 180, we can actually use that going backwards as well, which is what I want to do in the second example. So this one says the sum of the measures of the interior angles of a polygon is 3,240 degrees. How many sides does the polygon have? So we're given the sum, and now I want to find out the number of sides. So our formula again, the sum of the interior angles is n minus 2 times 180. In this case, we're given the sum. I need to solve for n. So our sum is 3,240, and we need to solve for the number of sides, or the variable n. So what I'm going to do first is I'm actually going to divide by 180. I could distribute this as well. Either way will work. 3,240, if I divide that by 180, I end up with 18. So 18 is equal to n minus 2. Which, thinking about the formula, what this represents is whatever polygon this is, I can split it up into 18 different triangles. And then adding 2 to the other side, we end up with the number of sides is 20. So a 20-sided polygon ends up with a total sum of the interior angles of 3,240. So there's the formula. That's how we can use it. It's very useful. N minus 2 times 180. It's definitely one that we should store away in our toolbox because we're going to keep coming back to it and we're going to use it a lot.